All right. So, due to the test will be coming soon this Thursday, we don't have time to review the quiz. So, several student has the really common mistake for the quiz one. So, I'm gonna very quickly go over record video, share with you. Hopefully, that is helpful for your future study. So, this is the quiz for consider two bus power system shown in this figure. It's really similar, not the same, because I changed the initial uh, voltage and angle in the second bus right there. I'm gonna draw in here. There we go. So that was given bus one, slack bus, bus two, the peaky bus, sometimes road buses. Specify rear power -2 per unit and -1 per unit. Why? Because the S base 100 MVA and then roads leaving from the bus. That was minus value. Okay. All right. So I'm gonna write there. Here we go. So the first questions is what? Um, by the way, so we're gonna using Newton-Raphson method, NR method. Just only one-time iterations. Okay, one-time iteration. It's very important. Okay. All right. So I'm gonna saving 03. Here we go. All right. Just give me a second. It takes more time. Here we go. All right. So the first question, determine line admittance Y and construct, the two by two Y bus matrix for the system. Why? Because this is just only two bus. Okay. So we learned before Y is what? Y is equal to 1 over Z. So diagonal elements are the sum of connect to admittance. So uh, this is the answer for, okay? So the which the diagonal form is sum of admittance connected to that bus. It's the all buses, okay? And then the off diagonal, um, okay. So the off diagonal is the negative of the line of admittance between the bus. So um, why y11 is only y sub 1 2. Why? Because go back to the figure 1. Oops, I'm gonna share it with here. Um, so could you see that right there? This is the bus 1. Just the only connected line is the transmission line from bus 1 and 2. So G is equal to 0.1. Okay. So y sub 1 2 is what? Minus J10. Maybe how about this one? The second bus is also the line transmission is like from bus 2 and 1. Just only one line. So that is also y sub 1 2 minus J10. And then y sub 1 2, y sub 2 1, as we said before, negative value of the line of the meters between the bus minus of a minus J10. So it's the equal to the J, the 10. Okay. So the finally y sub 1 1, y sub 1 2, y sub 2 1, y sub 2 2 is minus J10, J10, J10 minus J10. So if you have mistake from here, from this stage, or the answer is wrong. Okay, few student has mistake here. Very be careful. Okay, it's very important. Okay, now the question two. Using the general power flow equation provided below, the right, the rear, and reactive power the equations at bus two and simplify them for the system. Okay, so some students has the another formula equations for the active and reactive power at bus I. But as I said before, to escape there being confusions, I have noticed to you in here the P sub I and Q sub I in here. Some students like this one. No. Okay, you have to use this one two formula. I is 2, the K is what? 1, 2. Why? Why? Because the 2 bus. And especially, they're looking for what? Rear and reactive power equation at the bus tail. So we have to simplify, from this equation to with the rear, index, summing in here. So I'm going to show you for the answer for question 2. So zeta sub I sub k we learned before, okay, in here, okay. But delta sub I minus delta sub k, okay. So from the y bus, okay, the y bus, the g sub 2 sub 1 here, what? 0. Why? Because this is the J10. Maybe how about this one? The 10. Why? Because J10. How about the G sub T2? Still 0. And how about this one? B sub T2? Minus 10. Right there. So set that what zeta sub 2 1 is like the delta sub 2 minus delta sub 1. The delta 2 minus 0 is what? The delta 2. And the zeta sub 2 is the delta 2 minus delta 2 from this the equation is going to 0. So the initial value at bus 2 from the questions v sub 2 the per unit value v sub 2 0 and delta 2 0 is going to 0. Okay, so now the p sub 2 is, the k is equal to 1 2, and then I is equal to y because the second bus we wanted to be talking about. So that is from the original the equations, and also we're gonna to 1 and then 0 degree. Okay, so just plug in here. And finally, we can get the 10 times v sub 2 times sine some delta sub 2. Okay? Some student in here, right there. Oops. So in here, delta sub 2 1. But but delta sub 2 1 is delta sub 2 minus delta sub 1. Delta sub 1 is what? 0. Okay, so that is what I want to do. And then the Q sub 2 is the V sub 2, V sub 1, G sub 2 minus G sub 2 1 times sine zeta sub 2 1 minus B sub 2 1 times cosine zeta 2 1 plus V sub 2 times V sub 2 over G sub 2 2 times sine zeta sub 2 2 minus B sub 2 2 times cosine zeta 2 2. Okay? So the same thing, just plug in the V sub 2 1 and delta sub 2 is what? 0. So the finally minus 10 V sub 2 times cosine delta sub 2 plus 10 times V sub 2 square. Okay? Oh, I'm sorry. I'm sorry. This is wrong. Oh, this is wrong. Why? Because okay, this is the initial value. So that is why. Okay, so right now you don't need it. I'm sorry, right there. You don't need it. Just the we wanted to plug in for from the Slack bus. I'm sorry. Go back to here. The question. I'm sorry about that being confused. Uh, the bus one angle is the 0, and then the amplitude the is 1. Okay, here. This is the Slack bus. Slack bus is what? 1 0. Why? Because that is like the reference value. Okay, sorry about that. Okay, right there, here. So right now, you don't need we don't need to plug in the V sub 2 and then delta sub 2. Okay, just give me a second. I'm gonna go back to here. Okay, so right there, um, so the v sub 1 is 1 and the delta sub 1 is equal to 0. Then finally, we can express the P and Q at bus 2 in terms of v sub t and delta sub 2. Okay, v sub 2 and delta sub 2 to express the P and Q at bus 2 in here. Now, the question 3 here. Okay, oops, right there. Here we go. Using the initial guess. Yes, from these questions, we're gonna using the initial guesses. Okay, so compute real reactive the power mismatch at bus 2. So how can we find it? So we learned before the delta. The first number we have to find the delta P and delta Q. This is the P specific minus P sub the calculation. The delta Q is the Q specific minus Q the calculation. What is the specific value? Specific P is what's the given from the per unit value in the question in here. See that right there. Specify real power and reactive power. Here we go. Right there. Okay. So, but to keep in mind, this is the minus value. I'm gonna show you the answer. So right there. So using initial value, we have to find the calculation value. Okay. Oops. Sorry, my throat is really bad. So p sub 2 in here, 10 times p sub 2 sine delta sub 2. That is what we have already found. The simplified equation at bus 2. Just plug in the v sub 2 1, the delta 2 is like 0. 0 per unit. So maybe how about this one, the Q? Okay, 0. So 0, 0, value is what? Minus 2 and minus 1. Now, the Jacobian, the matrix in here, several student has wrong, the formula equation P sub 2 and Q sub 2, so that is why it's wrong, okay? So finally, the answer for 10, 0, 0, 10, I'm going to skip the calculation. And finally, sometimes the inverse, inverse J in here, usually J inverse. But in this here, very simple calculation, I can make it. So the delta in here, but derivation of v sub 2. And then this is the 0.2 what? Radian. A lot of students has mistake here. Very be careful, okay? And then we're gonna just change the degree minus 11.46 degree. How about this one? Minus 0.1 per unit from the equation. So finally, from the initial v sub 2 and delta 2, the angle and amplitude at bus 2, we're gonna just 1 minus the 0.1 and 0 minus 0.2 radian, and also we can transform this like the degree minus 11.4 degrees. So finally, v sub 2 after first iteration, 0.9 minus 11.4. Okay. All right. Thank you. Stop.